In this video, I'll discuss methods of detecting outliers. We'll use box plots and z-scores to do this. So we have several terms to talk about first, and then we'll see how all these terms come to play with the z-score and drawing box plots. An outlier can be detected in different ways. An outlier, first of all, is an observation or measurement that is unusually large or small relative to the data values we want to describe. We will use the z-score to detect outliers, and we'll look at the box plot to detect outliers today. The box plot can be used to detect outliers graphically. It is based on the quartiles of a data set along with the low and high data values, which give us a very useful 5-number summary of the data and their spread. So the 5-number summary comes from the upper and lower quartile, the median, and also the minimum and maximum value in the data set. The hinges are simply the upper quartile, the lower quartile, and the median. The hinges of the box plot are the upper quartile, the lower quartile, which is the top and bottom of the rectangle. Interquartile range, known as IQR, is simply the distance between the lower and upper quartiles. So it's actually a subtraction of the upper quartile value minus the lower quartile value. The inner fence is located at a distance of 1.5 multiplied by the IQR from the hinges. The outer fences are located at a distance of 3 multiplied by the IQR values. The whiskers are lines that are drawn from each hinge to the most extreme measurement, that is the minimum and the maximum value of our data set, to the inner fences. Here is a display of the elements of the box plot, and I'll talk about these details when we're actually constructing the box plot. So basically it's the vocabulary again of how do you construct the box, how are the whiskers drawn, where are the fences drawn, how to calculate lower and upper fence values, and these are going to be used to find any extreme values in the data set or outliers. We can interpret the box plot by looking at where all of the lines are drawn, how long the whiskers are, what the values of the upper and lower quartiles are. So all of these points we will be mentioning as we are constructing the box plot today. Other important terms that we'll discuss today and actually calculate deal with outliers and highly suspect outliers. Now we mentioned earlier that we're going to multiply our interquartile range by 1.5, and if we subtract that amount from our lower quartile, we will find outliers below the median, and if we add 1.5 times the IQR to the upper quartile, that will find any outliers above the median. When we multiply by 3, that's finding extreme values compared to our data. So we just want to point out that when we are looking for values that are below the median, we are subtracting the product from the lower quartile. When we're looking for outliers above the median, then we are adding 1.5 times the IQR to the upper quartile. In the case of rare event approach, this is when an experimenter hypothesizes a specific frequency distribution to describe a population of measurements. Then a sample of measurements is drawn from the population. If the experimenter finds it unlikely that the sample came from the hypothesized distribution, the hypothesis is judged to be false. With respect to the z-score, we can use the z-score to detect outliers algebraically. Observations with z-scores greater than 3 in absolute value are considered outliers. So that means if we have a z-score of 3 or higher, that would be considered an outlier. On the other extreme, z-scores of -3 and smaller, that is 3 standard deviations below the mean, those are also considered to be outliers. Let's see how we can use the z-score to detect outliers. A sample data set has a mean of 57 and a standard deviation of 11. Determine whether each of the following sample measurements is an outlier. So in order to determine if we have outliers, we'll use the z-score formula. Our z-value is equal to x value of 65, that's our given point, minus the mean of 57 divided by the standard deviation of 11. Since 65 minus 57 divided by 11 is equal to 0.727, we would determine that this z-score is less than 3 in magnitude, so 65 is not an outlier. Remember, in order to be an outlier, the z-score would need to be more than 3 standard deviations from the mean. This says we don't even have 1 standard deviation because 0.7 is below 1. Given the x value of 21, our substitution is the z-score is equal to our x value 21 minus the mean of 57 divided by the standard deviation of 11. The result now is negative 3.273. So we can see that this z-score is definitely more than 3 in magnitude. So 21, that original x value, is considered to be an outlier. Example C, we're given the x value of 72. Substituting that into the formula, z equal to 72 minus 57 divided by 11 is equal to 1.364. Since 1.364 is less than 3 in magnitude, 72 is not an outlier. And finally, 98 as an x value minus the mean divided by standard deviation of 11. The result is 3.727. So 3.727 is more than 3 in magnitude, therefore 98 is an outlier.